Today's lesson is 4.3, Solving by Factoring. Before we go ahead and get into solving by factoring, let's go ahead and talk about the zero product property. This is a property that says when I take any two quantities, let's just call them A and B, and I multiply them by each other and they equal zero, that either the A quantity or the B quantity or both of them must be zero. Think about it. 5 times 0 is 0. 0 times 5 is 0. And of course, 0 times 0 is 0. Let's go ahead and take a look at our first example. For what x values does f of x equal 0? I'm going to go ahead and apply the zero product property to this by taking first f of x and setting it equal to 0. Now I can go ahead and I can solve this using the zero product property. What the property says is that one of my two quantities, or both of them, must be equal to 0. This first parenthesis is going to be my A value, and this second parenthesis is going to be my B value. And the product's property says that for them to equal to 0, one or both of them must be equal to 0. So what I'm going to do is I'm going to take x minus 5 and set it equal to 0 and solve. Or the product property says 5x plus 2 is equal to 0. I can go ahead and solve both of these problems. For this one, I would simply add 5 to both sides, giving me an answer of x equals 5. There's my first answer. Perfect. And for this one, it's a two-step equation, so I'm going to have to subtract the 2, and then I'm going to have to go ahead and divide both sides by 5, it looks like. When I do that division, I'm going to end up with a fraction or a decimal. I'm going to leave it as a fraction. There we go. Let's try it one more time. In example 2, for what x values does g of x equal 0? So the first thing you're going to do is you're going to take the g of x and make it become 0. Pretty simple. And then you're going to think of this part as your A and this part as your B, and you're going to apply the zero product property, which says that A part, oops, I was going to write A instead of 2x, there we go, is equal to 0, or your B part is equal to 0, or both. And in the context of our quadratic functions, more than likely they will both be equal to 0. Because remember, quadratic touches the x-axis twice. There we go. So it looks like my first answer is a fraction. Okay, I'm at the bottom of the page. I'll leave it as the fraction, 1/2. I could change it to the decimal if I want. And it looks like the other one is going to give me an integer. Does this always happen that you get an integer and a fraction? No, we could get two integers, we could get two fractions. It just depends. What this property is doing for us is it's giving us the shape of our quadratic. So if we were kind of to take a look at our graph, I could graph this quadratic pretty quickly. I know that it's an upward facing quadratic because there is no negative A value. So I know the graph is going to look like this. I also know that it's going to touch the x-axis here at 1/2 and 1, 2, 3, 4 here at -4. I don't know where the vertex is per se. I don't know where it is exactly, but I know it's going to look something like this. This is what the zero product property is helping me to do. Okay, so I can use it to help me kind of get an idea of what the graph looks like. And of course, it is solving my x-intercepts, my zeros, my roots. All right, so let's go ahead and talk about factoring a quadratic. To factor a quadratic, we're going to take our quadratic in this form and we're going to factor it into this form. Oh, I need a different color. Hold on a second. I don't know what color to use. Oh, what color should I use? Oh, let's use this one. There we go. Okay. Now, if I were to actually multiply this out, here is what I would get. I can use the FOIL method, first, outer, inner, last, or I can use the double distributive method where I'm going to multiply x times x and x times e, and then I'm going to multiply d times x and d times e. So x times x would give me x squared. D times x would give me dx. E times x would give me ex. And of course, d times e would give me whatever d times e is. Since I don't know what it is, I'm just going to call it de. Now, what we would do in this case is we would take our two common terms right here in the center, and we would go ahead and combine them together. That would look like this. And of course, I would actually take those numbers D and E and I would add them together and put their sum in front, oops, in front of the variable X. And then of course, D and E would be a multiplication and would become a number. So take a look at this. This right here becomes your B, which is with your X. It's this part right here. And this part right here, this D times E, becomes your C, oops, which is this part right here. And if you look in front here, you have this part right here. Let me put the A there. And notice that what I have done, when I factor, I'm looking for two numbers that multiply to C, and when I add them, they give me B. So that's what it means to factor. I want to find the multiplication of the C term that adds to the B term. Now, for this first lesson of solving by factoring, we are going to keep the A value 1. In this case, we don't have to really mess with A and we don't have to worry about what A is. In the next lesson, we're going to talk about what to do when A is not 1, when A is bigger than 1. 2, 3, 5, 27. All right, so a very common way to factor is called the T-chart. Now, normally when we factor, when we have to solve by factoring, we're going to take that f of x and we're going to set it equal to 0. We're then going to want to come in and we're going to want to identify our A term, our B term, and our C term. Now, I know that the A term is, of course, 1 in all of these examples in the 3 that I'm going to do today. But it's very important that you do identify that. What you can do is you can come in with your color. This is why I love the color so much. I can come in and I can see that B is a positive 8 and that C is a positive 15. And of course, A is 1, just like I said. Now, a very common thing, like I said, is to make what is called a T-chart. It looks like the letter T. It's a little bit wider on the left side than it is on the right side. And that's done on purpose. What we're going to do on the larger left side is we're going to take our A term and we're going to multiply it times our C term. So we're going to do, in this case, 1 times 15. Well, let me just put my multiplications in there. There we go. And of course, 1 times 15 is 15. Now, what we want to do on this side is write down all the factors. So we want the factors of 15. How can you multiply and get 15 for an answer? Well, you can do 1 times 15. You can do 2 times, nope, 2 doesn't go in. 3 times 5. And the next one would be 5 times 3. Now, I don't need to put 5 times 3 because it is the same as 3 times 5. And I can make 3 and 5 work just like I can make 5 and 3 work. It doesn't matter. Um, Normally, when we do a T-chart, we like to keep numbers in ascending order. So they need to start with the smaller one and then get bigger for the first factor, and then descending in the second column, the larger number, and then they get smaller as you go down. Now that's common, but it is not necessary that you do that. You just need a factor. So if you have 15 times 1, that's the same, and 5 times 3, that's the same. Once you start repeating and just switching the numbers, you're done with your factors. Okay? These are going to be your D and E values. These are going to be your D and E values. And what you want in the second column is your B value. Now, it's very important with the B term that you make sure you know if it is positive or negative, because yes, it's going to make a difference. Well, how do I get that B term? I take my D and E, which came from my factors of C, and I add them together. So this little multiplication, I'm now going to change it to a plus. Since 8 is positive, everything is positive or everything is negative. That's the only way it can work. But remember, when I add a negative plus a negative, I get a negative. So everything is positive in this case. Let's go ahead and start adding. 1 plus 15 is 16, and 3 plus 5 is 8. Now you just play the matching game. Which one of these matches with this? Well, there we go. There they are, 8 and 8. That means that these two right here are going to be your D and your E values. So here's your D value, and here's your E value. Nope, there's the color I used. Okay, how do I put them into the factors? Well, 0 equals, I'm going to make my two parentheses. Just like I saw in example 1 and 2, those were considered to be factors. So if I just slide back really quick, this is what a factor would look like. Notice that it has parentheses. It has the variable that's being used in the quadratic, normally x, and then it has your plus or minus. When we get to the next lesson, you're going to start seeing fancy things like that. All right, let's go back. So I put x and x because that's going to give me this x squared term. And then the 3 is going to go here, and the 5 is going to go there. It's just that simple. One goes with one goes with the other. What kind of 3 is it? Well, it's a positive 3. What kind of 5 is it? Well, it's a positive 5, and I've gone ahead and factored. Now what I can go ahead and do is I can apply my zero product property to find out to solve this quadratic. So this would be my A term, and this would be my B term. And I'm just going to go ahead and I'm going to say x plus 3 equals 0, or x plus 5 equals 0. And I can come back in and I can solve both of these. They're simple one-step equations where I'm either going to add or subtract. Negative 3 is my first answer. I'm subtracting again. Negative 5 is my second answer. And that's it. I've solved. My two x-intercepts are at negative 3 and negative 5, and that is what my graph would look like. So I know my graph is upward facing. 1, 2, 3, 4, 5, and it looks something like that. That's what my graph looks like. I know it's a rough guess. I don't know how far down it goes or anything like that. I don't have any idea where the vertex is, but I know where the intercepts are. All right, let's try another one. So remember, you want to go ahead and change that f of x to 0. I know it doesn't seem like a very big step, but you need to make sure that you are aware of um, what you're that you're solving. Okay, you need it to be 0 to solve. My b is going to be -9 this time, and my c is going to be +20. All right, this one's going to give us a little bit of trouble because we have that negative b value, but a positive a and c. So I'm going to take my a value, which is of course 1, and I'm going to multiply it by my c value, which is 20, which of course gives me 20. I want to think of all the factors of 20. I need to make sure that I do realize it is positive 20. So here we go. 1 times 20, 2 times 10. 3 doesn't go in. 4 does though. 4 times 5. And my next term would be 5 times 4. Now, I know this seems crazy to think of, but I always start with 1, and then I always start in this one with 1, then I go to 2, then I check 3, then I check 4, then I check 5, then I check 6, and I just keep going until I get that repeat. Sometimes I have to use my calculator. 20 divided by 4 is equal to 5, so I would put that as a factor, 4 times 5. Sometimes I check 20 divided by 3. Nope, it's a fraction, so I don't put that as a factor. All right, then I'm going to go ahead and I'm going to put my b term over here. And remember, it's very important that it's negative. Oops, ooh, held it too long. There we go, -9. Now, I have to make it negative. The only way to do that is to make them both be negative. Okay, the only way to do that is to make them both be negative. Think about it this way. If the one was positive and one was negative, look right here, you would get a negative answer. That is -19. Great. But +1 times -20 is not +20. Positive times negative equals -20. So I can't have a positive and a negative. I must have a negative and a negative. If that's the case for the first two terms, then it must be the case for all of your terms. All of your terms must match. They must match down this way and they must match down that way. So whatever the first one is dictates the whole column going down. All right, or maybe it's a row. Now let's go ahead and add them. -1 plus -20, oops, is -21. -2 plus -10 is -12, and -4 plus -5 is -9. I need to find -9. There it is all the way at the bottom. And now I know what you're thinking. Oh, Miss, it's always going to be the last one. Yes and no. Yes and no. Sometimes, a lot of times, it is the last two terms that you think of, but that's not always the case. It really just depends on what that addition for your B term turns out to be. All right, so remember the pattern goes. You're going to make your two parentheses. You're going to put your variable in the front. Remember, we normally use x for a quadratic because we are graphing. Now you're going to put your 4 and your 5, and since they're both negative, you make them minus. There you go. Now you can go ahead and apply your zero product property, which says your first parenthesis has to equal 0, or your second parentheses must equal 0. And I know I didn't use my color here. I'm hoping that we don't need it, but I can bring it back if you think it's helpful. So there's my first answer, positive 4. And here's my second answer, looks like positive 5. As you do more and more of these, you're going to start to notice a pattern. You're going to start to notice a pattern with the number that you put inside the parentheses for D and E and the two answers that you get. You're going to notice that the sign inside the parentheses is the opposite sign of your answer. Yes, that happens every single time. Look, it happened up here. Plus, my answer's minus. Plus, my answer's minus. It happens every time because we're using that zero product property and we're setting it equal to 0. All right, I know you think you've got it and you're good to go, but I do want to show you one more. And this is because, take a look right here, my C value is negative. This is going to make a bit of a difference. And I just want to make sure that you have seen every possible factor before we go ahead and practice. So A is going to be 1, just like it has been. B this time is positive 13, and C is negative 48. I also like this example because 48 has a lot of factors, and it's good to see something with a lot of factors. So here we go. We've got A, which is 1, times C, which is, oops, hold on, C, which is negative 48. Yes, I'm going to put the negative in there. You bet your bottom dollar I am, because it's going to make a difference. This is telling my head that one of these two terms must be negative and the other has to be positive. It's the only way we can get a negative answer. Remember, you have that little guy, what is it? This one, right? The little triangle. It's been a long time since I've seen it. Let's go into the factors. So 1 times 48, you don't have to put the multiplication in between. I like it. I like it simply because it reminds me that I'm multiplying. What two numbers multiply to 48? So right now I'm just thinking 48. I'm grabbing my calculator. I'm going to check next 48 divided by 4, and I get 12. 5, I know 5 doesn't go in there because 48 does not follow the rule of 5, which means it has to end in a 0 or a 5. So I'm going to go ahead and try 6. 6 times 8. The only number in between 6 and 8 is 7. And if I try that, 48 divided by 7, I'm going to get a decimal or a fraction in my calculator. So I am done because my next factor would be 8 times 6. Now I have, like I said, B this time is a positive. So let me show you how to do this when you get a negative, and then B is going to tell you what kind of answer you get. So let's just look at the first term, 1 in 48. It is going to help us decide which one is positive and which one is negative. So I could have positive and negative, or I could have negative and positive. Those are my only two options. I'm not going to crisscross. I'm not going to do positive and positive because remember, positive times positive is positive. I can't do negative times negative because once again, negative times negative is positive. And so I must simply keep them straight across. So I'm going to do positive 1 plus negative 48. Well, that's negative 47. And then I'm going to go ahead and I'm going to do negative 1 plus 48. Well, that's positive 47. Now what I'm going to do is I'm going to look at my two answers. Yes, I know that neither one of them is 13, but what I'm looking for right here is which one is the positive like the 13. If the 13 was negative, then I would be looking for the negative answer. Well, this one is my positive. right here. So that means my answer, it cannot be this one, which means this is not positive, negative, and that is not positive. It has to be in this form to get me a positive when I add them together. If the one at the top is negative, all the numbers down this row are negative as well. And if the 48 at the top of the next one is positive, then all of these are positive as well. What this is doing, what this one little step is doing, is it's saving me a lot of time and it's going to allow me to find my positive 13 faster. Now I can simply start adding. Negative 2 plus 24 is 22. Negative 3 plus 16 is 13. Negative 4 plus 12 is 8, and negative 6 plus 8 is 2. Now, you might have been thinking, Miss, why didn't you just stop right here? Because it matches. You can. As soon as you get that match to the top of your column, to that pink 13 that you need, you definitely can stop. There was no need for me to answer these two questions. I could have left them blank because they're not the answer. I know that, but I just need to finish off the table. I don't know what it is. Maybe it's some OCD in me. Oop, there's my two there's my two terms that I'm going to put into my factors, and then I can go ahead and apply my zero product property and solve this quadratic. Remember, x always goes first, and then you just pop in the 3 and you pop in the 16. The 3 is negative, so you make it minus. The 16 is positive, so you make it plus. Now you're going to go ahead and you're going to take each one of those parentheses, set them equal to 0, and solve. Because remember, this is your A, this right here is your A, and this right here is your B for your zero product property. All right. Once again, what this is doing is it's showing me the shape of my graph. It's showing me the shape of my graph, and it's allowing me to see kind of what it looks like without a calculator. So my graph kind of looks like, ooh, that negative 16, huh? 1, 2, 3. And then 16, something like that. I don't know. I don't want to put 16 of them out there. But that's what it looks like. All right. Good luck, guys.